All right, everyone. So one of the things that I've been struggling with as we move online is the fact that we're going to be using the right-hand rule a lot. And to me, it's a very visual thing. And I've been trying to figure out how I could show you on a video how to do the right-hand rule. And I've also been worried about the mirroring effect if I am doing a selfie type video. So today what I'm going to try to do is take a video of my hand going through how I would do the right hand rule. And I have some examples here on this piece of whiteboard. I hope that this helps somewhat, at least to get you started with this whole process. So we learn in chapter 11 that the force that a charge feels as it moves through a magnetic field is given by QV cross B. Now V cross B is what we call a vector product or a cross product. And if you remember learning about that last semester, the answer of course is a vector, which is why force is a vector. And the way that we find the direction of V cross B is using the right hand rule. What we're going to also think about today is the fact that once we do V cross B, we also have to take into account the sign of the charge that's moving, because if the charge is positive, it's going to move in the same direction as V cross B, have the force. However, if you have a negative charge, the force it feels will actually be in the opposite direction to V cross B. So our first example here is we have a charge moving to the right, and I've indicated that the magnetic field is kind of pointing at an angle to up and to the right. One of the things I want you to think about right now is, because you know something about the cross product, is you know that the cross product of two vectors is perpendicular to the plane that they lie in. And so in this example right here, both the velocity vector and the magnetic field vector can be drawn on the piece of whiteboard, so they are lying in that plane. V cross B is going to have to be perpendicular to the whiteboard, so it's either going to come out at us or go into the board. So the way that I find V cross B is I take my hand and I lay it along the direction of the velocity. Keep in mind that sometimes I might have to rotate my hand to do the curl part. But right now, if I lay my hand along the direction of the velocity, and then I want to curl my fingers in the direction of the next vector, which is the magnetic field vector. So I'm laying my hand like this, curling my fingers like this. And the way your thumb naturally points, which if you notice it's pointing at me, is the direction of V cross B. And so I'm going to write that on this board, and I'm writing it like this. This is V cross B. And I mentioned in one of the videos that this is how we represent something in 3 dimensions when it's coming out at us. Imagine you're looking at an arrow, and the point of the arrow is pointing at you, so you just see the point, and that's how we draw it. If it was going into the board, we draw X's. I have some of those down here. And that's because you're looking at the back of the arrow, and so you're seeing like what would be the feathers. Okay, so that's the direction of V cross B for this first example. Because the charge is positive, the force is in the same direction. So I'm also going to draw something to note that that's also the direction of the force. Now, if I do the same procedure for this example, I do V cross B, my thumb points at me, and so I'm going to get the same result for V cross B. It came at me again. I did V, curled my fingers, my thumb's pointing at me. Notice I'm doing something a little dangerous for the right hand rules. I have a pen in my hand because I'm a righty. Sometimes when you're a righty, you tend to hold on to your pencil and start doing the right hand rule with your left hand, and it doesn't work because it's called the right hand rule. So word of warning to all our righties. So we found V cross B is out of the page again. It's the same example, so it shouldn't be a surprise. But we want to represent or remember that because of the fact that this is a negative charge, the direction of the force would actually be in the opposite direction. All right, moving on to this example, I wanted to just look at something that might be a little bit more difficult to do the correct right-hand rule. So like here, notice my magnetic field now is down and to the right. And if I hold my hand like this, I'm like, well, my fingers don't curl that way. You know, so I'm laying my hand along the velocity and I want to curl my fingers backwards. And so what I need to do is I need to rotate my hand so now my fingers curl the right way. And notice now you see my thumb pointing into the page or into the board. And so here I found that V cross B for this example is into the page, and that's also going to be the same direction for the force because this is a positive charge. And again, I'll do it for the negative sign, the negative charge, because it's good to see examples a couple times. Again, if I held my hand like this, I can't curl my fingers in the direction of the magnetic field, so I have to rotate my hand. So now I'm along V, and now I can curl my fingers in the direction of B, and my thumb is pointing into the whiteboard. So this was the direction of V cross B, but because it's a negative charge, the force is actually in the opposite direction. All right, two more examples. I wanted to sort of show something where one of the quantities was in or out of the board. So in this picture, our magnetic field is going into the board. That's why the X's are there. And so now, when I lay my hand along the velocity vector, like if I did this, again, I can't curl my fingers into the page or into the board with my hand like this, so I'm going to rotate it. And now I can curl my fingers into the page, which is in the direction of the magnetic field. And notice my thumb's pointing up. And so here is my V cross B. And this is also the direction of my force because it's a positive charge. And if I do this again for the negative charge, of course, I'm still going to get, for the negative charge, V cross B is still going to be up because it's the same right-hand rule I'm applying, but the force that that charge feels is going to be downward. All right, last example before you get too bored. I wanted to draw the velocity coming out at me, and so for the positive charge, I'm trying to represent the velocity vector coming out at me. The magnetic field is to the right. This one's a little tricky. So I'm going to have to hold my hand first with my fingers pointing at me, and now I'm curling my fingers in the direction of the magnetic field. Notice, of course, my thumb is pointing up. So my V cross B is up, and this is also the direction of that force for that positive charge. If I do the last one, I have the velocity going into the page, and so I first started with my fingers like this to go into the board, but you know, my fingers don't really naturally turn this way, so I'm going to have to rotate my hand so I can curl my fingers to the right, and notice here that my thumb ends up pointing down, and so that's, for this problem, the direction of V cross B, but because it's a negative charge, the force will be in the opposite direction because you're multiplying by a negative sign. So that's my attempt in trying to demo for you the right-hand rule. Excuse the messiness and the terrible camera holding, but I hope that it's helpful to see it being used in action. There are other ways to do the right-hand rule, and there are many resources online for you to see that. This is how I do it, and so this is how I teach it. And so I wanted to show you what I did. All right, hope it helps.